If you're looking to master all the laws of indices and get them all right when you do your GCSEs, then you've come to the right place. In today's lesson, you will need something to write with and something to write on if you're planning on having a go at some of the questions yourself, which I always advise. This is more likely to be a non-calculator topic in terms of questions on the exam, but if you want a calculator to hand to check any of your answers, then you're more than welcome to have one. We're going to jump straight in, so if you need a bit longer to read the task board, pause the video now. The laws of indices are used to simplify values or calculations containing indices. And just a reminder, when we've got a number, for example, 2 to the power of 5, written as shown on screen, the large normal number 2 is what we call the base, and the smaller 5 is the index or power. And remember, index is just the singular, indices is the plural. So when we talk about the laws of indices, we are talking about applying them to values that contain an index. One really important thing to remember is that the laws of indices can only be applied to values with the same base. 3 squared times 3 to the power of 7, they both have a base of 3, meaning I would be able to apply the laws of indices to that one. However, in this second example, 3 to the power of 5 times 4 to the power of 6, the first value has a base of 3 and the second value has a base of 4. Those are different and therefore I wouldn't be able to apply the laws of indices. So the top one's good, the bottom one is not. And so let's take a look at our laws of indices. We're starting with the multiplication law. It's the multiplication law because there is a multiplication taking place in this calculation. I'm going to show you why this works, but when it comes to answering these questions for yourself, you don't have to prove why it works or demonstrate why it works. You just need to be able to apply the law to get the answer. But it's important that you understand where that answer comes from. So hopefully by now, especially if you've watched my previous video on indices, you will understand that 3 to the power of 4 means 3 times 3 times 3 times 3. And that 3 to the power of 5 is 3 times 3 times 3 times 3 times 3. So in this first part, 3 to the power of 4 is 4 3's multiplied together. And the second part, 3 to the power of 5, is 5 3's multiplied together. And just a reminder that we are multiplying both of these things together, which is all of these 3's being multiplied together, which is 3 to the power of 9, which we could also get by counting how many 3's are being multiplied all together. What you may notice though is a quick way to do this would have been simply to add the powers, because we know we've got 4 3's being multiplied together and another 5 3's being multiplied together. Altogether that's 9 3's being multiplied together. So the multiplication law states that when we've got two values of the same base and we're multiplying them together, we can simply add the powers. Likewise with this one, I now know I don't need to write it out in full because I've got 7 to the power of 8 multiplied by 7 to the power of negative 2. 8 add negative 2 is 6, so it will be 7 to the power of 6. Here are two questions for you to have a go at. Pause the video now because I'm going to go straight through the answers. For this first one, so our base will remain the same at 12, and remember we are adding the powers because this is the multiplication law. 6 add 10 is 16, so we have 12 to the power of 16. And in this question, the base is 8. We've got negative 3 add negative 6, which is negative 9. And if you're not too confident with negative numbers, particularly the calculations using negative numbers, I do have a video on that as well, so feel free to go back and watch that one. Then we have the division law. And based on the multiplication law, you might be able to guess what's going to happen here. If we have 5 to the power of 9, I'm just going to use this space at the top here, that would be 9 5's multiplied together. And just a reminder, this is just to help you understand why the law works. You won't have to do this every single time you answer a question. You can just apply the law using a fraction to represent divide by. So 1, 2, 3, 4, 5, 6, 7, 8. Oh, I need one more. 9, 5's on the top, and we are dividing by 5 to the power of 3. So I'm just setting it out as a fraction to represent divide. What we're going to do is cancel top and bottom. So if there's a 5 on the top and there's a 5 on the bottom, we can cancel those out. So I could cancel this 5 with this 5, this 5 with this 5, this 5 with this 5, and then I've got no more 5s left on the bottom. And so it just remains to be seen how many 5s I have left on the top. 1, 2, 3, 4, 5, 6. So our answer is 5 to the power of 6. And you might have been able to spot or assumed, based on what we did with the multiplication law, that when we divide two values with the same base, we subtract the powers. So 9 take away 3 is 6, so 5 to the power of 6. And likewise with this second question, the base stays the same. We've got 5 take away 8, remembering that the order matters, don't get those the wrong way round, is -3. Here are two questions for you to have a go at. Remember, you don't need to write them out in full like I did. You can just go ahead and answer them. Pause the video now so you have more time to do those. I'm going to go straight through the answers. So we've got a base of 9, and if I'm subtracting my powers, 12 take away 7 is 5. So if you got 9 to the power of 5 for that first one, you would be correct. Then we've got a base of 20. -2 take away 5 would be -7. So if you got 20 to the power of -7, you would be correct. And then we have the power law. And once again, let me demonstrate how this one works. So in the bracket, we have got 5 squared, which we know is 5 times 5. But then we are raising that again to the power of 7. So that's like saying doing 5 times 5, 5 times 5, 5 times 5, basically 7 times, all multiplied together. So this 5 times 5 to the power of 7. So I'm timesing it all by itself 7 times. So if I go to times all of these little 5 times 5s together, what I've actually got is 5 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And looking at those values, you may be able to see a quicker way than writing all of that out like I did to get from the 2 and the 7 to 14. We times them together. So the power law, and that's where you've got one value with a power raised to another power, that's why we call it the power law, we multiply the powers together. So 5 to the power of 14. So with this second one, we've got a base of 9, and I'm doing 3 multiplied by -8, which is -24. Once again, here are two questions for you to have a go at. Pause the video because I'm going to go straight through the answers. We've got a base of 7. 4 times 10 is 40. So we've got 7 to the power of 40. And then we've got a base of 100. -4 times -5, well, a negative times another negative gets us a positive, so that will be to the power of +20. And then we have the zero law. And to prove this one, we're actually going to rely on the division law that we've learnt previously. Now remember, you don't have to prove this every time you answer a question, but it's important that you understand why it works. So if we take, for example, 5 divided by 5, we get 1. If I do 12 divided by 12, I get 1. And in fact, anything divided by itself will always be 1. That's a really important fact for us to remember. So if I create a calculation with indices, let's say I do 3 to the power of 7 divided by 3 to the power of 7. Well, I know anything divided by itself is 1. So I know the answer to this calculation is 1. What's that got to do with the zero law? Well, if we remember that when we divide, we subtract the powers, 7 take away 7 will get us the power of 0. But we already know that anything divided by itself is 1. So that shows us that 3 to the power of 0 is equal to 1. And in fact, that is true of anything. Any singular value raised to the power of 0 will always be 1. And if you're not sure, if you don't quite believe me, Type any number into your calculator. It can be a number in the hundreds, it can be a number in the thousands, whatever you want, and put it to the power of 0. It will always be 1. For example, 7 to the power of 0 will be 1. I could do -2 to the power of 0. Just remember, if you're inputting something like a negative into a calculator, to pop brackets around it so your calculator doesn't get confused, will be 1. Anything to the power of 0 will be 1, which should make this round really, really easy. In fact, you might not need to pause the video. I'm just going to pause for a couple of seconds because it will be long enough for you to write these answers down. Hopefully you got 12 to the power of 0 is 1, and 8 to the power of 0 is also 1. And then we have the fraction law. Now this one is a little bit more tricky, but we can do it. We'll get through it together. So we have got 16 to the power of a half. So just be careful, this isn't 16 and a half. It's 16 to the power of a half. It's not as easy to see when it's typed as it is when it's handwritten. Now, what this means, when we see a power with a fraction in, that's the same as a root. Again, if you've not watched my video on indices and roots, now would be a great time to make sure you've got those skills in place. So I'm going to start by drawing the square root sign and putting the base inside it, and that will be the same for all of these questions. The thing that changes depends on what root we are finding. So the number on the bottom of the fraction tells me the root. So this is the square root, and some of you might remember that when it's the square root, we don't actually have to write the 2, we can just draw the square root symbol. And they're really nice and easy when they are unit fractions, meaning there's a 1 on the top, because that just means we do our answer to the power of 1, but we don't have to bother writing the power of 1 because it's just the value itself. And so 16 to the power of a half is the same as doing the square root of 16, which is 4. 4 times 4 is 16, or to put it another way, a number times by itself to get 16, 4 would work. Let me compare that to this next one. So I'm going to start again by putting the square root symbol and the value 81. The number on the bottom of the fraction tells me the root. So this is the 4th root of 81, and then to the power of 1. When it's the power of 1, I don't have to bother writing it. The 4th root of 81 is asking me, what do I times by itself 4 times to get 81? And that would be 3. 3 times 3 is 9, times 3 is 27, times 3 again is 81. So the 4th root of 81 is 3. And with this final one, I draw my square root symbol and I put the 8 in ready. The 3 on the bottom of the fraction tells me it's the cubed root, but this time I've not got a 1 on the top, I've got a 2, which means I'm going to raise my answer at the end to the power of 2. The cubed root of 8 is 2, because 2 times 2 times 2 is 8. So the cubed root of 8 is 2, and then I square that, which is 4. Let me say that again. So the cubed root of 8 is 2, and then we square that, which is 4. A little bit more tricky, I know, so take your time with these next questions. Pause the video so you've got more time, and then we'll go through the answers. So we're starting with the square root of 25. The 2 on the bottom means it is the square root, we're sticking with the square root, and the 1 on the top of the fraction means we raise the answer to the power of 1, which is just the answer itself. So this one is simply the square root of 25, which is 5. Well done if you got that right. This next one's a little bit more tricky, so draw my square root symbol, put the 32 in. The bottom of the fraction tells me this is the 5th root, and then I'm going to raise my answer to the power of 3. So what do I multiply by itself 5 times to get 32? Well, that would be 2. 2, 4, 8, 16, 32. So that would be 2, and then I'm cubing that answer. 2 cubed, 2, 4, 8. If you got 8 for that answer, you are correct. Well done, that was quite tricky. And we have one more law to learn today, and that's the negative law. And what you can see here is we've got numbers raised to negative powers. All that does is convert the value into a fraction. So it's just a different way to express the value. The negative makes it a unit fraction 1 over. And then we write the base and convert the power to a positive. So it's still 3 to the power of 1, but the negative makes it 1 over. And then we simplify. 3 to the power of 1 is just 3. So this answer would be a third. For your next one, I've got a negative, so I automatically go in and write 1 over, and then it's 7 to the power of 2, because I can remove the negative, because that's what I mean when I put the 1 over, that replaces the negative. Which, if I simplify, is 1 over 7 squared. 7 times 7 is 49. And then our last one, I can see the negative power, so I go 1 over 5 to the power of 4, which, if I simplify, is 1 over, we've got 5, 25, 125, 625, if I multiply 4 5s together. Here are 2 questions for you to have a go at. Pause the video now so you've got a little bit longer and refer back to my examples to help you. 12 to the power of negative 1 is 1 over 12 to the power of 1, which simplifies to 1 over 12. 3 to the power of negative 3 becomes 1 over 3 to the power of 3, or 3 cubed, and 3 cubed is 27, so 1 over 27. We're now going to do some quick multiple choice questions to test those laws. So if you've got some notes in front of you about what to do for each law, that would be really useful at this point in time. I'll pop a timer on the screen for each question. However, if timers just don't work for you, then you can ignore it and pause the video so you've got the time that you need to answer each question. Here's your first one. We're using the multiplication law for 7 squared times 7 to the power of 8. And here are your options. And the answer was B, 7 to the power of 10. On to the division law now. And the answer to this one was D, 12 to the power of negative 4. On to the power law now. We've got 6 cubed being raised to the power of 2, or being squared. That one was B, 6 to the power of 6. We've got evaluate 100 to the power of 0. Here are your options. What happens when we raise any value to the power of 0? That's B1. On to the fraction law now. We've got evaluate 81 to the power of a half. So what is the power of a half the same as? It's the same as doing the square root, so that one was C9. And one last one with a negative power. We've got 5 to the power of negative 3. If you said C, 1 over 125, you would be correct. Well done. On to some independent practice now. This is the last part of this lesson. If you wish to just check your skills are up to scratch. We have got 8 questions with all of the laws in, all mixed up for you to have a go at. And I will be putting the answers on the screen straight away. So pause the video now so you've got time to do them, and hit play when you're ready to see those answers. And here are the answers. So go back through and check those. If there are any you didn't get correct, do go back and just rewatch the examples. It can help just to see and hear them one more time. And all that's left to say is a big well done for taking part in this video lesson today. Remember, every little part of revision you do will greatly benefit you in achieving your best at your GCSEs. Remember to like the video and subscribe for more video lessons. And if you like short form content as well, you can find us on TikTok and Instagram, where we post short quizzes and revision tips. I'm Charlotte. Thank you for watching this video.